Hello and welcome to another part in my Godot Weapons tutorial for VR. In this part, we'll look at adding some basic animation and sound effects when firing our gun. We'll probably need a few parts to add all the bits and pieces to complete the effect. Note that I have linked two videos in the description below. One is part of an episode of Mythbusters that shows a gun firing in slow motion. The other is a video that explains how our Colt M1911 works. Reference videos like these are really handy. We start in our gun scene. I'm going to add a spatial node that will function as a pivot. We'll use this in a minute to animate our recoil. I'm dragging the pivot out so it's behind our gun. My initial idea was to have the elbow as the pivot point, but I might move it so we pivot around the wrist in a future video. It has been a decade or two since I last fired a real gun. Now we parent our gun model to our pivot point. This way Godot updates the transform of our gun model for us. Note how when we rotate our pivot point, our gun moves. Because this scene is parented to our controller, this does mean our controller mesh does not move with our gun. As I want to replace our controller model with a hand and part of an arm, I'm saving that for another time. We also want to animate parts of our gun itself. For this I am turning on editable children. Note that our DAE import has created an animation player node. If our original model had animations, we would be able to access them from there. However, there are none and we won't be using this node. Our gun doesn't have many parts. We can't animate the hammer or the trigger. We can see an armature with a slide attached to it. I guess the model was designed to have animations in place. It may have gotten lost when the model was converted. We can move the slide so we can animate it ourselves. We can see that there is a magazine sticking out the bottom, but unfortunately it is not a separate part. We're going to add our own animation player node to our scene. I'm not using the one that was imported as we might risk losing our animations if the model is re-imported. We're going to create a new animation. We'll call this animation Fire. In order to animate our slide, we need to select it. We're going to animate its position, so we open the transform section. We want to add a keyframe with the slide in our starting position for frame 0, and we do so by pressing the little key icon next to our translation. Because we haven't animated this before, Godot will ask us if we want to add a new animation track, which we do. Let's move our timeline forward a bit. 0.3 seconds may do the trick. Now we move our slide into position. We basically want to move it as far back as we can without us creating a gap at the front of the gun. When we're happy with the position, we press the key icon again to insert another keyframe. We'll move our timeline to 0.5 seconds and zero out the position of our slide so it returns back to its starting position. Again we add another keyframe. We'll change the interpolation on our track to cubic. This gives a slightly smoother transition. Let's reset our timeline to 0 and play our animation. That was a bit slow for my liking. Let's change the scale of our timeline so we can more easily fine-tune it. You do this with the slider in the right bottom. Let's also change our step size. 0.05 seconds should do the trick. Now we just drag our keyframes a bit to speed things up. And we test our animation again. Better, but maybe a little faster. Yeah, that'll do. Now we're going to do the same thing with the rotation of our pivot. I've reset our timeline and selected the pivot node. We press the key icon again to create our first keyframe, and again Godot asks us if we want a new track. We'll also set this track to cubic interpolation. We move our timeline to 0.1 seconds, adjust the rotation of our pivot by 15 degrees on the x-axis, and add a keyframe. Now we go to 0.2 seconds, reset our rotation, and create a keyframe. That doesn't look too bad. Okay, next up we create a new 3D scene. We want to eject spent casings from our gun each time we fire, and for that we need a casing. I'm changing our root node to a rigid body and renaming it to casing. We'll place our casing in our object physics layer. We set our mask to environment and objects because that is what we want to collide with. We do not want to collide with our invisible wall, so we turn off the player layer. Next we add a mesh instance so we can show an object. We add a cylinder mesh to our object. This thing is tiny. We'll start with a radius of 1 cm and a height of 2. We'll save our scene in our Models and Weapons folder. Now we return to our gun scene so we can check our size a little better. But first we add in a spatial node that becomes a spawn point for our casings. Note that I add this as a child of our pivot so that it will move along. Let's move it in place. I quickly select our animation player here so I can position our slide to the backwards position. It is at this time our shell exits our gun, so we can line it up with our indentation. I'm changing our modifier mode to local space. I'm rotating our spawn point so we can control the direction in which our casing is flung from our gun. I then move our spawn point slightly outwards. Next we link our casing scene. We're only doing this temporarily so we can see the size of our casing. We can see that it is too wide and not oriented correctly. Let's go back to our casing scene to correct these. We'll start by rotating our mesh instance. I'm setting the x-axis rotation to -90 degrees. I'm changing the radius of our mesh to 0.5 cm and the height to 2.5 cm. Changing back to our gun scene, we can see that our casing looks an okay size. The player is never going to see one up close, so we're not too worried about the look. Before we continue, I'm going to change the size of the collision shape of our gun. This has bothered me for a little while. The gun always seemed to hover above the table because its collision shape was too big. It may also interfere with our casing. Switching back to our casing scene, our next step is to add a collision shape. We'll add a cylinder shape here. We need to rotate it to match the orientation of our casing. Now we'll start sizing it. Note here that the collision shape only has a precision in centimeters. We can't make our shape fit our casing exactly, but seeing it's such a tiny object, it's not really a problem. We do want to give our casing a little color. Let's select our mesh instance and create a material for it. We select a nice yellowish color for our albedo color. We increase our metallic so we get a nice and shiny looking material. And that means lowering our roughness as well. Once ejected, we don't want our casing to roll around the floor indefinitely. Our little gun won't shoot that many bullets, but we should clean up after ourselves. We simply add a timer to our scene, which I call lifetime. We tick one shot because we'll run our timer only once. We tick auto start because we want our timer to start running after we instance our scene. And we set our timer to 10 seconds. Next we need to create a script for our casing scene. For now I'm just clearing out some of the default code. Now we connect the timeout signal of our timer to this script. All we do here is call keyframe. This will cause our casing to be removed from our game. In order to spawn our casing, we need a function that implements this. We return to our script on our gun. We need to be able to select our casing scene. While we can hardcode this, I find it easier to create an export variable of type packed scene. We can set its value later on through the property manager. We add a new function called emit casing. First we instantiate a new instance of our casing scene. We set the transform of our casing to the global transform of our spawn point. Our linear velocity is set based on the orientation of our spawn point, but I am making a mistake here I will shortly rectify. Because I want to control this velocity, we'll add another export variable where we can set the initial velocity. We then multiply our linear velocity with this value. We need to add our new casing somewhere in our scene, but we don't want to add it to our gun scene or it will move along with our track controller. For this we'll add a spatial to our main scene, which I call spawns. Back in our emit function, we can now get our spawns node by calling getNode and using the path root main spawns. We call addChild on that node to add our casing node to our scene. Back in our gun scene, we no longer need our casing node, so we'll remove it. To spawn our casing at the right moment, we select our animation player and manually add a track by clicking on Add Track. The type of track we want to add is a call method track. This will first ask for the node on which we're going to call a method, so we select our root node. Now we right-click on our track to insert a new key. This will ask us which method we want to call. We select our emit casing method. The last step for our casing is that we select the root node in our gun scene and find our new casing variable. Here we select our casing scene. Now that we've made the visual aspect a little more interesting, let's take care of some audio. I have downloaded a few sample files from freesound.org. I have placed the links in the description. In order to play a sound, we need to add an audio stream player node. Note that there is a special 2D and 3D version of this node. The standard audio stream player just plays a sound at the volume specified, but the 2D and 3D variant can change the volume and pitch of a sound depending on its placement and velocity in the world. We are thus going to use an audio stream player 3D. To make use of this, we're going to place our player at our muzzle. Next, we need to select our gunshot sound file. We can test our gunshot sound by ticking the playing box. Just like before, we click on our key icon to insert a new keyframe, and Godot will ask us to add a new track for our sounds. Now you'll notice that our sound isn't actually turned on. The clip had finished playing by the time I created the keyframe. We can rectify this by double-clicking on our keyframe and changing its value to on in the property manager. Now the sound plays when we play our animation. We pretty much know the length of our animation, so it's time to shorten it to fit. This means that while our fire animation is playing, we know we can't do anything else with our gun. But every time we finish our animation, we're ready for another action. We'll be using that later on. Let's make sure our animation starts playing whenever we fire our gun. We simply add a line of code to our action function in our gun script that tells our animation player to play our fire animation. We have one more step to do. We only need to perform this step because we are using a separate viewport to render our scene with. In our main scene, we select our viewport and enable our 3D audio listener. And before we test our work, we need to fix a typo in our gun script. We need to use the X component in our spawn point's bases as the direction vector for our velocity. We can now hear our gunshot when firing. Note also the casings that are ejected from the gun. They are moving a little quickly, which we'll have to deal with. My laptop is really struggling when I'm recording full screen video like this. Without the recording running, it is a lot of fun seeing all the casings rolling around the floor, but I couldn't capture good footage of it. I don't know if it comes across in the video well, but the audio position is really cool. One thing I changed while recording was setting our gunshot sound a little lower. It was very loud initially. We also noticed that the casings were being ejected at a bit too high velocity. We'll adjust this down to 5. I'm also renaming the variable here just in case we add other velocity types in the future. I thought our gunshot sounded a bit flat. Now I'm no sound guy and I'm not going to give a full description of something I don't have a lot of experience with. However, it's worth going over a few basics so you guys have a bit of a starting point. Let's go have a look at our audio tab. It's worth noting that you can have multiple configurations of this in your game, but by default the moment you use the audio system, a default bus layout resource file is created in the root of your project, and we see that here. Right now there is only one bus, and that is the master bus. All sounds are processed through the master bus. This bus controls our overall volume, it controls where our audio is output to, and any effects you add here applies to all sounds. In games, however, we want far more control over our audio. One of the common features most games have is to be able to control the volume of things like music, sound effects, dialogue, etc. individually. In order to enable this functionality in Godot, we would create a bus for each of those groups, as I'm doing here. Note that each of these will send their audio to the master bus. This selection can be seen at the bottom of the bus. Now that we have defined these individual buses, we can write an interface for the user to either mute them or change their volume. That's for another day, however. We are purely interested in our gunshots, which is part of our effects bus, but instead of using this bus directly, I'm going to create a special bus specifically for our gunshots. The underscore prefix is just something I add to remind myself that this bus is not controlled by the user. From our drop-down list, we now select our effects bus to tell Godot to send our gunshot audio through our effects bus. Now we need to change our audio stream player and tell it to play its sounds on the gunshot bus. When we play our sound, nothing much changes, but we can see 3 buses are processing sound. The sound gets sent to our gunshot bus, which routes it to our effects bus, where our effect volume is applied, which finally routes it through our master bus and our master volume. We want our gunshot bus to do a little extra, so we click on the Add Effects bus and we select the reverb effect. This effect allows us to simulate the sound bouncing off of things. We're in an enclosed space in our gun range, so now that sounds pretty cool. When we click on the reverb effect, we can see that we have a bunch of settings. I'm sorry to say that I have no idea what each one does. Again, I am not a sound guy. I'll leave it to you guys to just play around with the settings. I tweaked them a little to make our gun range sound a little less hollow. One last thing I will mention about the audio buses is that you can also control them with area nodes. Say for a racing game, we want the engine sound to sound different when we're in a tunnel. We can set up an area with a collision shape for our tunnel, and then specify which alternative bus to use. Combine this with area masks on your sound effects, and you can control which sounds are affected. At this point in time, our gun fires every time we pull the trigger. If we rapidly do this, we could fire our gun at a high rate, and our animation will keep restarting each time. We don't want this. We want to simulate that we can't fire the next round until after it is loaded. Lucky for us, we know when the next round is loaded, because our animation will have finished playing. We can thus implement this simply by checking if an animation is playing when the trigger is pulled. In our action function, we add a line of code where we're checking if our animation is playing. We'll add a not in front of that, so our code only runs if no animation is playing. It doesn't make sense for a VR game, but for a desktop game you might want to play an idle animation here on a loop. You would thus check if that idle animation is playing instead. What we also need to keep track of is how many bullets are left in our gun. For this we add an export variable called ammunition. I have no idea how many bullets this gun holds, so we'll set it to 12 for now. Now, in our action function, we're going to check if we still have ammunition, and only if so, we run our fire code. I'm adding an else in here with a pass for now, but we'll get back to this in a minute. Now we decrease our ammunition by 1 every time we fire. We want to play a different sound when we try to fire our gun when empty. We need a separate audio stream player for this, so we should rename our current one. Now we can add a second audio stream player 3D to our scene. This one I'm less worried about the position. Next we select our sound file for this sound effect. We need to add a new animation for this. We'll call that empty click. Just like before, we'll add a keyframe for our audio player. Godot will ask us to create a new track, and because I forgot to reset the time, I need to drag our keyframe to the start. And I also need to turn playing on. Finally, we can change the duration of our animation. Now we edit our script and we make sure we start playing our empty click animation if our gun is empty. Again, playing the animation will result in us not being able to pull the trigger again. Last but not least, we have to make sure our audio player plays on our gunshot bus and we adjust the volume as well. Now, this next part is a little hard to demo in a video, but I'm going to show the code changes anyway. Now we want a little haptic feedback when we fire our gun, and in the current implementation of AR/VR Server, you can set a rumble value on each controller. The problem here is that we don't have access to this from our gun script. For this, we're going to add a little bit of logic to our pickup function script. When we pick up our object, we're not only going to give it a reference to our pickup function node, but we're also going to give it a reference to our AR/VR controller node. This is always our parent, so we can just call getParent. While we're here, I'm also going to add some signals for when we pick up and drop an object. We won't use this in this video yet, but this will come in handy later. We simply emit these signals at the right time. It seems to me it's also handy to include what has been picked up in our picked up signal. In our pickable object script, we now need to add our parameter and store this in a variable. We also need to clear this variable when we are dropped. And just for good measure, we'll use Godot's new typing system to make sure we know this variable is an AR/VR controller node. In order to add our rumble value to our animation, we need to have access to this. I've implemented this by creating an export variable which becomes a pass-through to the rumble value on our controller. Our setter sets the rumble value on the controller, and our getter gets the rumble value on the controller. If someone has a better way of doing this, please leave a comment. Now we go back to our gun scene and select our animation player. Here we add a property track and we select our main node. Then we select the rumble property. We've done this a few times now, so I'll fast forward through most of this. We create keyframes for our rumble so it quickly ramps up, holds for 1/10 of a second, and then goes back to 0. It works, but unfortunately you'll have to believe me. Next up, I want to do another small change for something that has been bothering me for a while. Our main room is nicely lit from above, while our gun range gets light throughout the range. But the table on which our gun lies is very dark. As this is somewhat unrelated to what this video is about, I'm going to fast forward through most of this. I'm simply creating 2 CSG cylinder shapes to create a light fitting and adding a spotlight. We're not using our GI here. This gets saved to a subscene which we then include 5 times in our scene. I also want our spotlights to cast shadows. In normal situations, this would work after we turn shadows on. However, we are rendering to a viewport and our default shadow atlas size is not set up. So we select our viewport and set our shadow atlas size to 4096. Then, in our spotlight scene, we can turn on shadows for our lights. And there we have it. We can now see our gun lying on our table. When we pick it up, we can see that it nicely casts a shadow on the ground. We covered a lot of ground, but there is still more to do. In our next video, we're going to start looking at reloading. This will require us to use both hands, so we'll have to look at the implications here. After that, I want to look into muzzle flashes and related effects. As always, I would appreciate a like if you enjoyed this video. Please consider following me on Twitter for more regular updates. Until next time.